So in this video, I wanted to continue illustrating row reduction using this app that I've made. So let's use different requirement here. Let's require that the matrix have rank 2. So what that is going to do is going to require that there's only going to be 2 pivots, this whole matrix here. And just for a little context, suppose that we're solving some kind of system of equations, and this is the augmented matrix for it, where you have maybe this line right here represents the equation for x plus 5y plus c is equal to -4. So what we're going to do is just the row operations that we usually would do. So what we would typically do is we'd start here. We divide this whole row by this -17, make this 1, and then use that to clear out the rest of the things down here. Typically, we don't really actually like to start with the 17 because that would involves dividing by 17 and make the numbers kind of messy. We might prefer to divide by 3 or by 4 because those are easier to handle by hand. In theory, we should be able to do it in the app. However, as I'll mention in a later video, there are sometimes bugs when it comes to dividing by big numbers or doing a lot of arithmetic, kind of like how if you did it by hand. So let's just start with the easier step, which is to move this 4 up. And now we'll use this 4. We'll divide this whole row by 4. So what would we do? We stick R1 now. With that earlier step that we did, we interchanged R1 and R2, writing something like this. And now we have R1 up here. We're going to take R1 and we'll divide by 4. So we get 1 5/4, 1/4, and -1. So let's do that here. Click this. Then clicking this will click it again and it will normalize this row. As we get down here. Now what we want to do is we'll deal with the 3 first. Take R3, place it with R3 minus, so we're going to use this 1 to get rid of the 3, so we need 3 of them. We'll take this, multiply by 3, it'll be a 3 like this. So let's calculate -3R1. So what is that? That's going to be -3 here, and then -15/4, then -3/4, and then 3. And we're going to add this to R3, which is here. So that would be added to this, give 0. That's what we wanted. We want to use the 1 to make this into a 0. Now we add this to this. We want to write this in terms of divided by 4. So this is going to be -3 is -12/4. So now if you add these two, you're going to get 27, -27/4. We add this here, just -3/4. 3, here we get 5. So this row right here should now be this. So let's do that here. We're going to use this 1 to get rid of this. 27/4, -3/4, 5. So that's what we have here. So now we have a 0 here. So I guess we have to get rid of the 17 now. I mean, you might hope that in some way it would clear up, but you still have to get rid of this. So let's take this 1 here. We'll take the 2, the row 2, and we're going to replace it with row 2 plus 17 times row 1. So let's we want 17 of this row, so that when we add it to this, it gets 0. So what's 17 R1? That's going to be 17. And then, oh, sorry, 17 here, and then 17 times 5. So if you do 17 times 5, it's going to be 35 and 50. So it's 85. So this is going to be 85 over 4. This is going to be 17 over 4. This is going to be minus 17. So now we're going to add this to this row right here. So add it here, we get a 0. That's exactly what we wanted. Add it here, well, -1 is 4 over 4. So when we add it, oh, sorry, -4 over 4. So we add it here, we're going to get 81 over 4. Now we add -2 to this, so -2 is -8 over 4. So we add -8 over 4 to this, so we get 9/4. 2 and this, we get -15. So when we use this 1 to get rid of this, that's what we should get. 0, 81 over 4, 9/4, -15, which checks out. If we ever happen to make a small arithmetic mistake or something, we can always undo. So let's clear all of my writing there. Okay, so what do we have? We have this pivot here, the 1, and nothing else in this column. That means that we have solved for x. Now we need to then move on to solving for y. What we want to do is take one of these. We'll take this one, I guess. We will turn this into a 1, and we can use it to clear out the rest of the column. However, we might not want to turn it into 1 right away, because you see this dividing by 4. So it'd actually be nicer arithmetic if you just clear it out this way. Unfortunately, the numbers are going to be a little messy, so to just illustrate the idea, we'll just use the app. So we'll use it to clear this out, clear that out. See, that completely vanished. So let's undo that. Let's see that by hand, that this right here is just a multiple of this. So let's take, the way we would cancel this out from this is that we take R3, replace it with R3, plus some copy of R2. So what that should be, what should that be? I need to divide by 81 and multiply by 27. So that when I plug 81 in here, it gives me positive 27 over 4. And also 27 over 81 can be simplified. Because what is this? 27 is 3 times 9. 81 is 9 times 9. So these cancel on this and gives you just 1/3. So this is 1/3. So let's calculate 27 over 81 R2. So R2 is going to be 0 here. We already said that if you multiply this, sorry, this right here, R2, times this, 81 over 4, 27 over 81. This is the reason why we chose this number. These cancel, you get 27 over 4, which is this basically, except with the negative sign, without the negative sign. What about -3/4? Well, that's just times 1/3. So that is going to be threes cancel, and you get -1/4. Now 5 times 1/3. Sorry, I apologize. Ooh, see, this is a mistake. I need to use this row here. And I was using this negative 3/4, so that's not good at all. Okay, so let's go back. So we have this 1/3 times 9/4. So these cancel, and you get 3/4. So this is 3/4 here. You got to make sure you're scaling the right row. And then this times 1/3 is going to be -5. So what happens? When you add this to this, you get 0. 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 So this right here, this new row should be all zeros. So let's look at the drawing. So that's what we would do if we did this operation here. So now we have all zeros here. This is going to be our pivot, so let's turn it into 1. We can actually do that by hand. Let's undo that last step. We had R2. Replace it with, that would be 4/81 R2. So what would that be? Well, 4/81, the reason why we chose that number is so that this would become, sorry, this is still 0. This right here becomes 1. Now 4/81 times 9/4. So these cancel. 81 is 9 times 9. So this would just give you 9. So it's 1/9. -15 times 4/81. Now what is 15? It's 5 times 3. So if I pull out a factor of 3, I get 5 here. And then if I pull out a factor of 3, this is going to become 3 times 9. So instead of 9 times 9, it's now 3 times 9. So what is this? This is -20, or I can just write here. -20 over 27. So that's what this new row should be once I do the scaling. So let's see that. So we have 0, 1, 1/9, -20 over 27. So we have that. So we see our pivot here. So this is indicating that it's in row reduce echelon form. There's all zeros here, zeros up here, zeros up here. Down here, I mean. Here's our row of zeros on the bottom. Row of zeros should always be on the bottom. So these are our pivot columns. And these are non-pivot columns. So like I said earlier, if we were trying to solve a system of equations like this is the x, y, z columns, then what would this be? This would be x plus 1/9 z is equal to -2 over 27. And then also y plus 1/9 z. That's the second row. Is -20 over 27. And then what would the solution, the vector x containing x, y, z be? X, y, z. Well, we just plug in the things that we solved for. Well, actually, z here is going to be free. So let's say z is t, free parameter, so that we're not mentioning the variables anymore, basically. It's just writing in terms of parameter. Well, z is t, so we have t down here. X is -2 over 27 minus 1/9 z, which is just 1/9 t. 2 over 27 minus 1/9 t. Same thing here. This is going to be -20 over 27. minus 1, 9 t. Now we'll break it up in terms of constants and the factors that have t in it. So here we have the negative 2 over 27. This is the negative 20 over 27. This only has t's, so this is 0. Now we look at the factors that have t's in it. Negative 1/9, negative 1/9, and there's 1t. So negative 1/9, negative 1/9, and 1. And this is just the solution when you get if you wrote it down. Okay, so we will go on to another example.